Hey, for our next talk, it is my pleasure to introduce Pavel Odintsov, who is the author of FastNetMon. He's going to talk about what FastNetMon does, DDoS protection, and how they use ClickHouse. So Pavel, go ahead and take it away.
Hello, everyone. I'm Pavel. So I work for FastNetMon, and I wrote the original version of FastNetMon. It was started about 8 years ago, quite long time. And when we actually started, our main mission and goal was to help our customers to detect DDoS attacks. But it changed in this time, and I'll introduce you like how our project involved, what kind of challenges we had with data processing, and how actually we find out our company as data processing company more than cybersecurity company. So our product uses open core approach, and we have great communities. We have great bunch of people who actually really passionate about DDoS attacks, processing data. And all the time, I will be more than happy to answer any of your questions. So you can find all my social media contacts. So all the time, if you want to talk with him, just drop me a message. And what is FastNetMon? Actually, it's a tricky question because for 8 years, it changed a lot. Originally, FastNetMon was started as DDoS detection tool. It doesn't sound relevant to this meetup because we're talking about data. But this time, because of demand of DDoS attacks, and a DDoS attack is quite abstract thing because, you know, all the time, if you experience DDoS attack and if you're familiar what kind of DDoS attacks your network experience or your company experience it's just beginning. It's just beginning because all the time after company was hit by attack, we need to write postmortem and we need to provide some insights, what actually happened. We need to provide great visibility about dynamic of attack. And that's how we started adding more and more features like traffic visibility. And for now, as part of our project, we offer different types of cloud visibility. We can ingest logs from Amazon AWS, VPC flow logs. We support the same VPC flow logs from Google Cloud. And in addition, it's more for on-premise deployments and for telecom operators, we have great support for BGP protocol. And so from this perspective, FastNetMon can be explained as tool, as network automation tool, which can run some specific actions in response to some dynamic changes in your network. It sounds quite complicated. And for my next slides, I will try to explain what we're actually doing. So let's show you how FastNetMon works. I expected this diagram may scare people. Let me talk a little bit around it. What is it? Like, because we are talking about data, and in the center of this diagram, you can see FastNetMon. Just to explain what FastNetMon is doing. FastNetMon is a great aggregation engine. So what we are aggregating, why we are aggregating. So on the left side, we have different data sources. And when I say data sources, and of course, what kind of data they produce. And on the top of my slide, you can see example of data, what we have in place. So from left side, you can see switches, network equipment, borrowing, routers, borrowing, some data sources from public cloud providers. And from their side, we receive information about traffic. So in quite terse format, network equipment or cloud itself, they provide information, what kind of packets, what kind of network packets they receive it or send. And then this information may be used in different ways. Just to explain in well-known words, what kind of data we have inside. Inside of information received from equipment, we have source IP, we have destination IP, we have source port, destination port, number of packets, packet length. It's not very specific for networks, and everyone working with cloud environments, they are very familiar with what kind of packets we have. They may be UDP packets, TCP packets, all kinds of them. And what is tricky about it? Why we cannot like read this data directly? Why we have so many formats? Because network equipment is implemented very efficient way, which is efficient not for human beings, but efficient for hardware to generate. I would call it's not just developer unfriendly, as typically we explain data in quite not nice format. I would call it developer hostile formats, because many vendors, they interpret RFSs different way. They encode data very different way, and that's actually reason. And again, with public cloud providers, all of them, there are no standard about ways how you can actually export data from cloud provider, because for routers and switches we have two different families of well-known protocols like S-Flow and NetFlow, but for cloud providers there are no protocols. It's something in JSON encoded in quite a vendor-specific way, which is under control of specific cloud company, and so it makes things complicated. And especially because many large companies, of course, you may know that like lots of companies, they run completely in cloud, but more than about large companies, very large companies, they have two approaches. They keep on-premises in infrastructure and they keep cloud, and that's how problem begins. So we need to ingest data from different network equipment. We need to ingest data from network routers, from different clouds, and then we need to aggregate it. What I'm saying, what do I mean by aggregating this information? Because from the left side, if we ingest information about packets, like packets arrived right now, then more like 5 more packets arrived, 10 more packets. But this data is not useful for us, because for many real applications, it's not important for us how much traffic specific IP has. Like we don't care. But more useful and more real application, as they need data in different format. Actually, what we need to calculate what is the velocity of specific data stream, because like that we had some like random number of bytes for specific virtual machine in Amazon. It doesn't say anything, but that's why we actually inside of FastNetMon we have very high efficient flow parsing and flow aggregation engine, because as first level, because we have different protocols, we aggregate, like we process data in same format, which is unique for us, but it's standard for every single protocols we have, and then we aggregate this data. And when I say aggregate, so instead of input information, what you can see on top of this page, it's like how much bytes we have from specific IP, what kind of protocol. But after FastNetMon's processing, we have it different way. So instead of saying like we received 5 packets for last 5 seconds, it doesn't say anything. We can say it in very, very more useful way. We can say it like for specific host, which is an example 10, 1, 2, 3, we received 100 megabits of incoming traffic and 200 megabits of outgoing traffic. And what actually happened inside of FastNetMon, we aggregated data for specific host for a specific period, and then we calculated it. So, and then this data may be used for different approaches. It may be used for DDoS detection, because we may check, is it like malicious flow or not? Or we may think, we may change something about this traffic, or we may decide to block it completely. And this one is just one of the levels of aggregation, because network, like everywhere in networking, we operate not only on basis of IP addresses, but more of basis of prefixes. And FastNetMon can create any number of different aggregation on network basis. So instead of like just calculating what was incoming bandwidth, outgoing bandwidth for just single host, we can aggregate, for example, for a set of hosts or specific /24 network, which has 255 hosts. And then according to this information, we may decide about it. Again, you may create some specific group to understand like what is the traffic for your specific front end, like because you have some expectation that it may generate like 100 gigabits, and then you can see significantly more or significantly less. You may, for example, even create Prometheus alert, or you can just notify your network team like something going on. And that's why this talk, you hear this conversation deeply about networks on this meetup. We need to store this data. That's how our journey started. So our journey started from Graphite, and then we moved away from Graphite to InfluxDB, and where are we now? Right now we are on ClickHouse. So why? How it was in dynamic? let's move forward. My explanation was, I suppose, what cost abstract. That's what system administrator see when you're on a FastNetMon. Like this one is just number of incoming packets per second, outgoing packets per second, megabits flows for every for all top talkers in your network. And just to understand scale, even in quite medium-sized network, you may have millions of active hosts. So now you can understand what is the challenge. And what you can see on this screen, it's top K request over millions of hosts, which may be tricky. So, and I will explain why it will be tricky. So you can understand like what kind of data we have, but only on this screen, it's just a small chunk of data we have in FastNetMon. It's just one of the levels of aggregation, and we have way more of them. So, because FastNetMon, it was built for DDoS detection, and DDoS detection in case of FastNetMon is quite simple. It's not about machine learning, like artificial intelligence or some heuristics. It's just about specific actions. We call them thresholds. You set threshold and one specific level of like abstraction, aggregation, for example, IP address or specific network or group of hosts exceeds specific value, like your backup server exceeded more than 1G of capacity, and you never expected it to do it this way. And then you need to alert your network administrators and then do what we can do and why it happened. That's how it works. Very simple. And because of customer interest in all our aggregation, instead of just offering this information somewhere inside of FastNetMon, we realized that we need to expose as much as possible data to customer. And you can see here, it's like, it's not very well known product called Grafana. So, and you can see different level of aggregation. So left side, it's highest possible level of aggregation, just total traffic, how much we have incoming, outgoing. On the right side, it's aggregated over different prefixes. And again, even like medium-sized network may have hundreds and thousands of prefixes or even more. And on the right side, right bottom side, it's a worst possible scenario. It's specific host. And again, we may have tens of millions of hosts in our network. And we need to store all this information somewhere. And it was a challenge for us. So in this one, because previously on previous slide, it was just like specific traffic for specific prefix, specific IP address. But this one is more complicated. This one is what we call top K request. And that's how we actually kill our databases we used previously. It's very easy because we need to select from enormous data set. We need to, in this example, we just select just 10 top hosts or top entities by traffic. And it puts lots of challenge for us because for customers, it's most interesting request because all the time, if something weird happening in your network, you need to find out like what is the largest source of traffic or target of traffic, and then you run top K request and try to find out what's going on. What is the problem? When I mentioned that like lots of different devices or public cloud send information to us, I did not mention scale. We are talking about one of the largest deployments of FastNetMon. It has 1.5 millions of incoming messages per second. And they have more than 16 millions of unique active hosts in their network. And it puts lots of challenges, how we actually just receive this data, how we parse this data, and how we actually aggregate this data. And backend time, so it was one of the problems. And second problem is that we store traffic because we have no option how we can actually compress this information. It's not some specific value which can be put in some like small value like unsigned int 8-bit or something small. And we need whole range of unsigned int 64-bit values. So not so many options how we can actually compress the data, and data arrives in large data sets to us and customer like top K request and so, and we need to do something because we cannot just drop like, don't run top K request because it will kill our engine, will kill our product, and you will not able to receive this data. We need to do something. We need to offer customers something, and we did. We started with Graphite. it was more than 7 years ago, a long time ago. And back in time, I suppose we haven't got great choice of options, because when you Google TSDB in back in 2015, and then I suppose only Graphite came up. It worked well for us for a very long time. And now, of course, on this slide, I mentioned a few most annoying features for us. And first one, of course, it's dot as delimiter of metrics, because we operate with IP addresses, which use dot as delimiter. And same with prefixes. I also use dot as delimiter. And all the time it was quite annoying. Instead of using something like 10.00.001, we have to use 10_0_0_01. It's annoying, but we can live with it. But our largest problem with Graphite was performance. Quite fast enough, we realized that we cannot scale it more than 200,000 metrics per second. And we tried to find out options, what we can do. And we found some of them. And so that's how it was in 2015. Just to imagine, like I previously showed you nice dashboards from Grafana, but it was a real user interface of our product, because for Graphite we had only option, and Grafana was started, I think, one in 2016 or around that time. It wasn't very known project back in time, but I'm very happy to see like existence of Grafana, because it's great, because you don't need to deal with something like this one. It worked, but you know, you need to create dashboard all the time manually for every year case. And so we hit performance limitations. So you can see how much CPU carbon cache uses for this specific case. It wasn't large deployment of FastNetMon. Literally, it was one of the test labs we used for testing our product. It had just a small network as input of traffic. But you can see it's 21% of CPU. It's not that much for FastNetMon, but problem is carbon cache is single-threaded, implemented in Python. And so just like multiply it by 5, and then we will reach limitation of single CPU core, and then after that we're out. So we have no options how we can actually scale it more. And of course we must scale it more than 1 million of metrics. We have way more of them. So like our first optimization was quite fast. We realized like, Python, what you can do is it? And here you go. We found a great project called GoCarbon. It's literally, it's re-implementation of metrics daemon used by Graphite in Go language. And you can see for exactly the same load of 200,000 metrics per second, it's just 10%. So this way we were able to scale up to something like 2 million metrics per second. It wasn't bad, it wasn't good, it was something to work with. It was great for beginning of our product, but we got more and more larger, I mean, medium-sized and larger customers. It wasn't enough for them, and we tried looking for different options. In FluxDB, so it worked very well for us. It was really great for deployment perspective, because it's just single Go binary. It works on every platform. No need to compile, no need to install some custom repos. Just drop binary and it will work fine. But problem is, you can see lots of our complaints about InfluxDB. But for most of the cases, InfluxDB worked way better for us in Graphite, because it used a way more compact approach for storing data. It was able to process more data. But unfortunately, we hit limitation of InfluxDB quite fast, because around same numbers as Graphite, it wasn't able to process all data. And we started looking for different options. And unfortunately, for quite many years, we had no different options. We just like tried to live with InfluxDB, and we had plenty of problems with InfluxDB. One of the most annoying is that you just stop InfluxDB daemon and then you start it again, and you need to wait something like around 15 minutes with not that large data set. Like, I mean, not our largest customers. And so we tried to find out what is the options we have. And surprisingly, we realized that ClickHouse is just great for metrics, just wonderful. Again, like greatest feature from ClickHouse, we can stop thinking about cardinality. Like really, let's compare. Its diagram just compares like what was our experience with InfluxDB and what was experience with ClickHouse. And cardinality is one of the largest problems for us, because even medium-sized network may have tens of millions of hosts. And I'm talking about protocol of IPv4, because for IPv6, it may be hundreds of millions of unique metrics and like unique hosts in network, because they may be allocated per service base, they may be randomized different options. And from our experience, InfluxDB explodes and dies around 1 million of unique series. That's all, end of story. But we need more, we need way more. And we just want to stop thinking about what our cardinality is, because it's completely unpredictable for us, because it may be small network, it may be an enormous like network. And then all the time we need to change how much text, how much like unique series. Well, it's hassle. And in ClickHouse, we don't care. And it works with any level of cardinality, because it's not exactly a time series database in terms of what like we had under impression we get managed to something. And so, and bandwidth of ClickHouse is just enormous. We had no customers who actually reached scalability limitation for ClickHouse. I'm pretty sure ClickHouse has some of them, but I suppose it should be an enormous number, because for now we have plenty of active deployments handling more than 10 millions of unique series per second. And ClickHouse is not like largest contributor to CPU and disk load on those machines. So it just works fine. And so we have no problems with top key requests. Of course, it's need time, because it's need to read lots of data from disk space, but it can be finished in reasonable time. And when I say reasonable, we are happy even if it finishes in 5 minutes. With InfluxDB, it finishes typically in with or out of memory crash or just daemon hang up. That's all. No options to just, but in ClickHouse, we just wait. It's a little bit longer, but it works perfectly fine. And so our choice for metrics now is ClickHouse. But was it that simple for us to introduce ClickHouse as metrics engine? Like roadblocks, scary name, but actually most of my tickets to ClickHouse just complete most of the nonsense. Like, because you can see here just two different questions about how I can actually compile it's on ARM64 machine, because we offer our product on ARM platform and we need to like offer like our database on ARM platform. And so I started like chasing folks like, can I compile? How I can compile? And so I got my response. And second case, it was mostly just miscalculation, like misconfiguration on our side. We actually tried to push more data sets, like more columns than we actually have in database. And that's why we kill it. And two of them, just a few minor things. So it was completely like, it was very simple for us. No roadblocks, no blockers, no complicated things. But what was unusual? Unusual was that we can actually get rid of cardinality problems. And it opened a great way of using ClickHouse, not just for metrics. Also, we can use ClickHouse to store every single flow we receive from network equipment or flow from cloud VPC endpoints. And on this slide, you can see exactly the same data as I explained on the first slide. It's source IP, destination IP, some meta information like input protocols, TTL, and we can put this data into ClickHouse easily. So it's not limited just to keep data which was pre-calculated by FastNetMon. We can actually keep push raw data in the database. And it wasn't simple. This one, in this case, we have to implement different approach to aggregate data again. So that's why I call FastNetMon as a great aggregation engine. So we need to aggregate on different levels, because when we push metrics about what is the bandwidth, what is the packet rate for specific IP address and network, we do calculation just once per second, and then we push every single metric as enormous blob of data to ClickHouse. Previously for Graphite or in fact it was the problem because like even their protocols expected to have some reasonable size of inputs data sets. But what we push into ClickHouse, sometimes we push multiple gigabytes of data, and ClickHouse handles them very well. But problem with data, because we receive flows one by one, and we cannot insert them into ClickHouse one by one, because that's not how ClickHouse was built for. And this one was quite tricky I would say it wasn't quite tricky for us, but we had like multiple mistakes. So first thing, we tried obvious option as buffer table. Unfortunately, it didn't work for us well, because maybe, I don't remember reasons, but it's failed to insert everything what we need into main table. And then that's why we implemented our custom implementation, because we share same language as ClickHouse. We use C++ for development of literally everything in FastNetMon. And we just created buffer, which typically creates batches about 10,000 of different packets, and then pushes them into ClickHouse in single transaction. And from our side, it was just single, I would say, thing which was different from databases we used before, because we expected that we need to push every single packet one by one. And quite fast, we realized that it's not working that way. It's not that efficient. And when we switched to new approach and create enormous batches of packets, it started working just wonderful. And so it's not just about storing data, because with many databases, you actually can put lots of information into database, but when you start reading it, you can expect that dataset to explode, or it will not finish ever, or it will just, lock, because the amount of data is enormous. But with ClickHouse, it just works just wonderful. We have many customers with data sets exceeding tens of terabytes. And because of data is shared over day basis, monthly basis, hour basis, it's extremely fast for FastNetMon. Even make some crazy requests, like select every single flow for last day and count how much traffic we had from Google. Like, you cannot imagine this kind of request previously, because it will kill your database immediately. It will explode because of like enormous a number of disk reads, or you run out of memory. But this ClickHouse, you just need to wait a little bit longer, maybe half minute, and then here you go. And even with distributed setups with many machines, it can be so fast, really. So, and even better, it's not enough for command line, and because this one is crazy SQL syntax, which is for many people still quite complicated. And we can do it from Grafana, which is great. So same data, it can be filtered on different boundaries, different levels. Like you can receive this data with great precision. You can say for sure how much your customers or your virtual machines did request to Google's 888 service, like in specific amount of time. And you will get this information. It's just great for security purposes, for audit purposes, or just for out of curiosity, because it's nice data to have. And we are really happy about ClickHouse, and our experience with ClickHouse is just great. And so we have a really large community built around of FastNetMon. Most of our folks are network engineers, data center operators, different ISPs, cloud companies, and many of them are making great steps into data, because everything is data. So they're trying to move from old pipelines of data processing built by their vendor, and typically they look like black boxes, like you cannot change anything. Instead, many of them just moving to something well-known in industry, like Grafana, Prometheus, InfluxDB, ClickHouse, and they're trying to work like leading industry standard tools to work with data. And typically back in time, nobody used data processing tools for work with network data. It was just completely isolated set of tools. But what we can change now, it changes, and we can use exactly the same tool for working with network data, on different kinds of financial analytics, advertisement, just many types of data, and we can unify it this way. And thank you for listening. And if you have any interest in network security or DDoS attacks, join our communities. We have a great set of people, and we will be happy to share our ideas and our experience with FastNetMon. Thank you.
Thank you so much, Pavel. Great talk. We have a couple questions. So one here is, why did you not convert the IPs to ints? That's first one that came up early in the talk.
In which I support, let me show. Actually, I think we do. Actually, yes, we do convert them into ints. So
okay.
for storing a database, we convert them into ints. But in one case, actually, when we save them for metrics names, because metric name can be literally anything. It may be just like short name, it's maybe just name, Latin name, short name, and that's why in this case we use just strings for customer convenience, because then in Grafana they will be able to find out like it's not just like 1, 2, 3, 4, 5 and something like meaningful for customer.
Yep. Good. We'll take one more quick question. Pavel, what is your order by in your main table? Which I take it we're looking at that right now. How did you get to this order by on the first, right from the start?
Not actually. It's actually one of the things we change quite frequently, because for different companies they have different interest in like this one. It's like because current one is about source IP and destination IP, because like most of our customers are interested in checking what was data exchange between specific IP addresses. But for many customers, they are looking for different options. That's actually why in our product we offer options to override it. And a customer can create and change order by for their own purposes, because, and also we have different case actually. We recommend customers to create different code duplicates of same data, order different ways. So because if customer want to keep option to select data by source IP and destination IP, but in same time they want to have very fast access using for like source ASN and destination ASN, they literally just duplicate data just to keep it fast, or they just change default order key.
Okay, great. I will have to close there because our next talk is coming up. Thank you so much, Pavel. If people have other questions, feel free to put them in the Q&A.